Let's look at now the couple, which is pure bending. So, okay, what it says here, what is the net effect of the two forces on the wheel? You can clearly see it's a twist. Net of all the forces along horizontal is 0. Okay. Okay, another application says here, what is the effect of the 30 Newton force on the lug nut? So that's the nut being applied and that's 30 Newton force. So what is the effect on this nut? These are the things, the kind of things that we are going to go through in this lecture. So 2D moment, there's no need for me to go into the details. You know this already. What is torque? That is basically the moment being applied. And you know what moment is that is basically the force being applied into the distance here. The tendency is basically, if it shows here, D is always the perpendicular distance, okay, from the point where you want to measure the moment. If I want to measure the moment at this point here, then it's this distance, and it's a perpendicular distance, okay? D is always perpendicular. That's another example being given. You're applying a force and it's always a perpendicular distance from the point where you want to measure the moment. So as shown, D is a perpendicular distance from point O to the line of action of the force. Line of action. Very strange. Why not distance from point O to the force? No, they are using the word line of action. I will show you what that means, okay? Here we've got another scenario. We've got this D being applied, line of action. Okay, I can explain it here very easily. Okay, the force. If I ask you to calculate the force moment at point here A, which is A, then what will be the moment? I need force into perpendicular distance. So that's the force. My perpendicular distance is, oh, that's a bit strange. This is not my perpendicular distance from force. That is strange. How am I going to calculate moment in this scenario? Can anyone help me, please?
So we can take d cos theta for perpendicular
horizontal.
Okay, so basically what you're saying is the perpendicular distance. So we can take, instead of this distance, we will take the perpendicular distance here. Am I right?
Yes, sir.
Yes, sir.
Yeah, but my force is up here. It's not
but we consider
here.
the line of action. So the line of
Yes,
action is
line of action. That's the thing what I'm after. Line of action. Remember, one thing you remember every time. If there's a force being applied, you make a straight line, extend it, which means this is the line on which the force is applied. That's the line where the force is applied. Okay, and this line is the perpendicular distance from this extended line, which is this one, D. Okay, so that's, therefore it says here line of action. Line of action doesn't mean the point where the force is applied. No, it means if there's a force being applied at any one point, you draw a line, make life easy for yourself. Draw a line, and then it means, it means that this line, the distance, perpendicular distance from this force line, and it is basically here. The other way around, which you will get the same answer, is that you can get the component of this force out. Remember, there are two forces, there are two components, that's this one here, and then this one here. So that's component, I will say y, and this is component x here. Okay. Now the y component multiplied by the r distance will give me the same result. The x component, which is not being applied here, the x component is applied here. Okay. There's no perpendicular distance for the x component. So the x component does not create any moment at A. Only the y component creates a moment. Let me see if I've got another, if I have another picture. No, I have to spend time on this one. Okay. Now let me explain again. Two ways to calculate the moment. Force line, that's this line, and perpendicular distance from the force line, that's this. So that is F into D. The other way is I can get the component of force which is perpendicular to the R, and then multiply by R. So this is Fy. So Fy multiplied by R, that's X, no, multiplied by R gives me the same result. So there are two ways of doing it. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay, so there are two ways, remember. Force line is a much better option. Anyway, let's move on. So the direction is defined by the moment axis, which is perpendicular to the plane that contains the F and Y. So basically your right hand rule tells you the direction of moment. So basically, if this is the point where I'm measuring the moment, as that's the force being applied, then force into distance gives me an anti-clockwise direction moment, which I can figure out from the right hand rule. So if the force was being applied in this direction, and that's the distance d, then you curl your fingers in the direction of the force, and the moment would be in this direction, and it will be clockwise. So sense of rotation, you need to understand this. You visualize it in which direction it tends to rotate. Okay, yeah, put it here also. Yes, force line. This is interesting. Okay, so it says here, for example, M naught, that's point O here, that's one, is equal to FD. This is the force being applied. That's the force applied, and it's in this direction. And what did I say? If you got a force, you make a straight line through it. And then is the perpendicular distance from that line if you want to measure point for a moment at O. So for example, MOFD, and the direction is counterclockwise, because if you look at point O, according to O, there's a tendency to rotate in this direction. So that is anti-clockwise. Okay. There's another way. You can divide this force into two components shown here, Fx and Fy. This is where we will use widely, because if you've got a number of forces being applied, then this method is much better. So same force being divided into two components, X and Y. So then if I want to measure moment at point O, it will be Fx. Let me draw the force line. That's the force line for Fx. So Fx into distance b, which is from here to here. So that is Fx into b. It is, if I look at point O, the Fx is trying to rotate the component in this direction. So it is clockwise. Clockwise moment is taken as negative standards. And if I look at Fy, now let's look at Fy. So I've got my F, let me write this somewhere here, minus Fx into B. This is my force line for the Fy, and then its perpendicular distance from O. So that would be Fy into A. That's this distance A. This is A. And if I look at the tendency for rotation at this point, Fy is trying to rotate in this direction. So this is counterclockwise, so this is positive. So the moment m naught basically would be Fya plus Fx, sorry, minus Fxb. That's your moment. Or I can do it, or m naught is also equal to F into D. If I look at this scenario here, I've got my force F, and that's D here. It's your call. You will see what information is available, and then you have to use that method in calculating the moment. Is this clear to everyone?
Yes, sir. But
Yes, sir.
but I'm having trouble visualizing how is Fx going in the clockwise direction.
Okay, let's do that. Let me just clarify that. Let me get rid of this. Sorry. Okay, so how come Fx? Okay, now imagine there's only one force Fx. So I am applying the force. Force line, important. Extend the line. This is the force line. And this is the moment here. So my distance is B, which is from here to here. And you can clearly see the force F applied wants to rotate it in this direction. That's my Fx. It is trying. My pivot point is O. Imagine O is your pivot point. If I apply force Fx, is it going to rotate the ball B in clockwise or not?
Yes, sir.
Is it clear now?
Yes.
Similarly, if I look at Fy, this is my force line, okay? Force line. And this is the distance A. Okay, I'm looking at this point. So that's my distance here. So I can simplify this into this problem. That's distance, and this is the force being applied Fy. And this is my distance A. Now the tendency, if I'm applying Fy force, the rotation, the tendency to rotate at point O is in anti-clockwise direction. So that's how we basically figure out the direction of rotation. Is that clear?
Yes, sir. Thank you.
Okay, let's move on. So what it says here is that using this approach, which I just mentioned, note the different signs on the terms, clockwise, anti-clockwise. The typical sign convention for a moment is in 2D is that counterclockwise is considered positive. Remember, counterclockwise is positive. We can determine the direction of rotation by imagining the body pinned at O and deciding which way the body would rotate because of the force, just like I mentioned. Okay, so resultant moment. What's the resultant moment? What it says here, you obviously know this is sum of all the moments, like resultant force. The resultant moment about point O, which is here, can be determined by finding the algebraic sum of moments caused by all the forces in that system. So what it says there, I've got force F3 being applied, F1 applied, F2 applied. I want to find the moment at point O. Then it would be F1 into perpendicular distance D1. The rotation is counterclockwise, so the moment M1 will be positive. If you look at F2 and its distance, tendency is to rotate clockwise. So my moment because of F2, my M2 will be negative. If I look at F3, with respect to O, the rotation is in counterclockwise, so it will be my M3 will be positive. Now I have to sum all the moments. If I ask you to find the moment at point here, sorry, I'll put it here, make it life easy. Then it would be, watch, force line and its perpendicular distance for F1 is force line and its perpendicular distance for F1, that was F2, this is F1, and a force line and its perpendicular distance, that would be my M3 then. Similarly, if I ask you, I want to find moment at this point, then again, remember, because engineers make big mistake here, force line into perpendicular distance, that is my moment M2 because of F2. Similarly, for F2, I've got a force line multiplied by its perpendicular distance. This will give me my M1. And force line multiplied by its perpendicular distance. This will give me my M3. So remember, force line, line of action, important. Okay, let's move on here.